Okay, good morning. Welcome to
FamilyMath1024.
FamilyMath1024. So yesterday we studied a really neat thing from the Calculus 7 blog about reflections. Mm-hmm. And what was the idea? Why don't you see if you can, from memory, sketch one of our reflections of, say, e to the x. What did it do?
So it just kind of went down like this. The idea was to try to preserve the derivative at x equals 0.
Okay. Yeah. So, and then as we did a couple higher approximations as well, and we preserved not just
the derivative, but like the second derivative.
Not just the derivative, but the second derivative. Yeah,
something like that.
Yeah, it was really interesting. And we studied this kind of idea, this broad idea of extending functions or approximating functions by matching derivatives and higher order derivatives in calculus last year. And what was that subject inside of calculus called?
Taylor series.
Yeah. So for Taylor series, the idea is if you have a nice, sort of well-behaved function like e to the x, we can say that near x equals x naught, f of x is approximately f of x naught plus f prime of x naught times x minus x naught. Am I still on camera?
Yeah.
Plus f prime, double prime of x naught, x minus x naught squared over 2 factorial plus da da da. So you do the same thing, you match all the derivatives. And you can also then see, if you only match, say, like the first two, the value of the function and the first derivative, there's infinitely many choices. But if you want to match the second derivative, you have to match it here, but there's still infinitely many choices for the further ones. But this leads to some nice function definitions, and today we're going to look specifically at e to the x. Do you remember what the Taylor series for e to the x was around x equals 0?
I think it was 1 plus x squared over, or 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4th over 4 factorial to the top.
Yeah, so in a way it was a very straightforward series with factorials. 1 plus x squared over 2 factorial. And you can see a nice property of e to the x is what? What's a nice calculus property of e to the x?
It is its own derivative.
Okay, and does that happen with this series?
Yeah, because when you take the derivative, the 1 goes away, x goes to 1, x squared over 2 factorial goes to x cubed over 3 factorial goes to x squared over 2 factorial.
Okay. So it has this series, this infinite series has that nice property. And what I saw last week that we're going to study today is a combination of this idea with this idea, e to the I theta.
This is cosine theta plus I sine theta.
Cosine theta plus I sine theta. So we have two very important properties that e to the x has. It has these two properties. It has the super nice Taylor series, which turns out to extend and be true for when, not just for when x is a real variable, but when x is a complex variable. And e to the I theta equals cosine theta plus I sine theta. And what that means is that if we look at e to the ix, where x is real, the real line is mapped to the unit circle. So at 0, I get, 1, e to the 0 is 1, and then you wind around the unit circle as you move along the real axis. So it's actually a really interesting map. But a guy on Twitter named Berger Dillon showed what does this look like what does this map look like if you do the approximations. So that's what we're going to take a look at now.
All right.
Okay.